I don't know, we'll see.
Ariana probably.
She's supposed to, we'll see if she shuts up.
She's been showing up on the other one. Bro, what am I supposed to do with this?
Oh.
Like, I'll move it, but.
All right, we're gonna do the bell ringer. Remember, I need missing work either tomorrow if you have it, or somebody's gonna drop it by Friday if it's on paper.
I ain't got nothing to make up some good. Do that next Friday. I don't think I have anything else I missed from this week.
As long as we get that one thing fixed today,
What one
that you
thing?
didn't finish yesterday, did you bring it back? Didn't you take it home?
I'll bring it tomorrow.
Okay.
It was laying on my nightstand. I finished it.
All right. Now, what you got here?
You got it, table notes?
Yeah.
Barrel in first.
Bell ringer first, I was gonna make sure I had these. All right, so bell ringer. Go ahead and click on submit. I'm just gonna talk you through them. I may write them up on the sideboard there. What is the atomic number? Tell us. That's that little number at the top of the periodic table.
I don't know.
Number of what?
Proton.
Protons, very good. Number of protons. Number of protons, so type that in, I'm gonna write it up here, number one. Two, what does the mass number tell us? What gives us the mass number?
Neutrons.
Neutrons and
Protons.
protons. It's the sum of neutrons and protons. All right, how do you determine the number of neutrons?
Is that mass minus the proton?
Very good. Mass number minus protons. And then, how do we determine the number of electrons?
Protons minus the neutrons.
No. Electrons, for what we're doing, will always equal. Remember, we had three
Percent.
columns that were the
Is it the
same?
What's the question?
Number of electrons,
Atomic number.
atomic number, same as protons. Or you can say same as protons. And then 5, how do we determine the number of protons? What number do we use?
Atomic number.
Atomic number. All right. So make sure you submit, that's your 5 extra points, credit points for today. All right. Now, we're going to do notes. So do you want them on, you do them on the computer? Did I give you one already? You can follow along if you want.
Thank you. Thank you.
All right, so we're gonna go here. So, oops, let me get on the right there. We're going to do our periodic table next. You'll want your periodic table as well because you may want to, write or color on it. So you may want to write or color on it as we go through.
That's
on another.
That's forgot this one.
Yeah, it always, for years, it always does it.
I haven't, they can't get this week too.
All right. Let me get this up. Slow today.
Yeah.
Remember, I always put vocabulary there, but we just kind of skip it.
Where's the
I know, I wanna go back and, this thing is in my way.
Come on, dang.
Here we go. Here's our periodic table, so, we'll cut the first row of lights off and see if that helps, sometimes there's a glare on it. So remember, this is how we organize the elements. Elements 1 through 92 through uranium are naturally occurring. Anything above 92 has been man-made. So, you can find periodic tables online. You can find them color-coded, similar to this. You might see them like this. Always look for a key. All right, so on here, we have a key for the coloring of the symbols. So gray is solid, blue is liquid, red is gas, and if it's just outlined, these are synthetic, which means man-made. We have these color codes around it so that it tells you if they're noble gases, non-metals, light metals. This one's broken it down into different types of metals. And then you have a key down here that tells you about what's inside the box. So always look for your key on your periodic table. And it's just our way of organizing so that we can have them, and by organizing them the way Henry Moseley did, we have them by atomic number and therefore chemical properties. So that's the importance there. So we're going to start with our periodic table. Groups are our columns. If you can't remember columns go up and down. On your periodic table, notice there's a number on top of each column. You've got some that have an A with them and some that have the B with them. We'll do the most with the group that has the A with them. Some numbers starts with 1 and goes all the way to 18 without having the A and B. So it's just a little bit of difference. That group number, especially the way it is on here, tells you the number of valence electrons. So group 1 here, 1A, has 1 valence electron. That means that's the number of electrons in the outermost energy level. It's the ones that's going to be reacting. Group 2, that's 2A, is 2 valence electrons. We skip this middle section here because their valence electrons does wacky things. Okay? Then we're going to skip over to 13 here, which on yours is 3A. This is 3 valence electrons. And then it keeps going 4, 5, 6, 7 until you get to group 18 or 8A, which is 8. Except helium. Helium is in group 8 because it's stable, or 8A, group 18, but it only has 1 energy level and only 2 valence electrons. It makes it stable, so it's a little bit different. It's an exception. So, because of these valence electrons, if you're in the same column, you're going to have similar chemical properties. So they're going to react with other elements in the same way. And so in a minute, if you want to label your periodic table, you can when I get to the next slide. Or I'll show you a shortcut where you don't have to write everything that's on there. So here, notice how they did all that. Well, your numbers already have the 1, the 2, the 3, 4. We're only looking at the A's. You can circle the 1 in that first one in 1A, and then right out to the side, valence electrons. That way you know that that number represents your valence electrons. When we take a test or quiz, you will have, in the directions of your test or quiz, you'll have a periodic table image. Or if you have this one handy and you're here, you can pull this one out to use. And if you're at home and have a printer, you can print the file to have one at home. So you don't have to label all of them, just know These in the middle do wonky things with their valence electrons, and at this level, we don't really worry about them right now. So we have some group names. So 1A is alkali metals. So you may want to write that above 1A on your periodic table. These are the most,
I have to put it.
you could write it on the periodic table right above here, alkali metals. They are the most reactive. And as you go down, they become more reactive. All right, as you go across in each group of metals, their reactivity increases as you go down.
Hold on. Okay.
Now, hydrogen is in this column, but hydrogen is not a metal, it's a gas. Hydrogen is there just because of its one valence electron only. Now, 2A, or group 2, is the alkaline earth. So you can write, turn your paper to the side, and above 2A, write alkaline earth metals on your periodic table. These are also reactive. They're not as reactive as group 1, but they're still reactive. We're skipping the middle. Wait a minute. No, we're not. I told the first class wrong. This is 3B here. 3B is rare earth elements. So 3B is rare earth elements. I don't really do much with that one at this level. Then this whole area here is the transition elements. So you can just label this whole middle section with all the B's, transition elements. We're going to skip over to halogens, which is group 7A. Halogens, these are your most reactive gases, or nonmetals rather, and they work opposite of metals. As you go down, their reactivity is less, so it decreases. So the most reactive is going to be at the top there. So 17 or 7A is halogens. And then you have the noble gases. These are non-reactive. It takes a full outer energy level to be stable. They're not going to run and react with anybody. Any other elements, they want to stay by themselves. Oops, I'm sorry, I thought there was one more thing. So they have 8 valence electrons, except for helium that has 2. So if you didn't get these names on your periodic table, you'll get a chance in just a minute. It'll come in handy because whatever I have you write on this periodic table will be there on test time if you use this one.
I'll have to use them.
You got that? All right, so if you didn't label it, this row starting with lithium is alkali metals. This is alkaline earth. Hold on. And an alkaline earth right there. This one is your rare earth metals.
Smallest rock.
And I didn't even realize that's what that was. No. And then this whole section here in the middle, they're lumped together as transition metals. And then the next few, we usually use just the first one, the next 4. So this one is going to be the boron group, so that's 3A. This one is the carbon group. So then this one is the nitrogen group and the oxygen group. Why these don't really have a specific name is because if you can see by the colors, they're kind of a mixture. Some textbooks will call them sort of the mixed elements. because it's kind of a mixture of metalloids, metals, and non-metals. Then this is your halogens.
It's not.
So 7A is halogens. And then 8A is noble gases. We'll do a lot with the first two columns and the next to the last column, and then some within here. And then once in a while, we'll deal with one of these, but. All right. Besides columns, there are periods. Periods are the rows, and they go across. So if you want to, on your periodic table, you can number 1, 2, 3, 4, 5, 6, 7, straight down. So start out beside hydrogen and just number straight down. There's 7 periods. These tell us the number of energy levels.
Well, last at the bottom.
They're actually, see this empty spot here? They actually fit in here, and if we put them there, it pushes the periodic table where it won't fit on one page.
Okay.
So they just drop them down, and most of those
Why is there so many now?
after
It's like
uranium, the ones after uranium and then those that come up here are man-made. They don't have anything better to do than come up and create new elements. All right, electron clouds, or we have, that's the area outside the nucleus. You'll see the term shells if you take chemistry later, and energy levels. Where I use energy levels. They hold a certain number of electrons. So you're going to see an example in a minute. The first level, which is closest to the nucleus, can only hold 2. This is helium. Helium has 1 energy level and it has 2 electrons. So it is stable because that energy level is full.
Right, so.
Hydrogen also has 1 energy level, but it only has 1 electron. That's why it's over in group 1, because it has 1 valence electron. Level 2 can hold up to 8 electrons. Level 3, for our purposes, will hold 8. Once we get to 8, we'll jump to level 3. Now, if you're in here in this transition area, then it gets complicated because at certain times it'll bounce around. And level 4 can hold up to 18, but for our purposes, it's going to hold whatever's left over after we filled up the first 2, 1, 2, and 3. It can actually hold more than 18, but so we've numbered ours, so you don't have to do anything here. So those are your 7 periods, 7 energy levels. All right, so here's an example of what I was talking about here. Here's magnesium. And in magnesium, if you find magnesium on the periodic table, and the easiest way is to look up right here, these red dots. That's group 2. So magnesium is the second one in column 2. So it has 2 valence electrons. That's the 2 red ones. It's in period 3, so if you've numbered it out beside sodium, you're going to put a 3. It has 3 black circles around that nucleus. And notice that there are 2 on the first, there are 8 on the second, and 2 out here. That's a total of 12. Oops. So there are 12 protons, and in the ones we're doing, there's going to be 12 electrons. To find the neutrons, if you look on the periodic table, the atomic mass, which is underneath the symbol, it's rounded to 24. Subtract the atomic number, which is the protons, and you get 12 for the neutrons. Tomorrow, we're going to practice drawing these. I've got it in a slideshow where you'll drag and drop. All right, so metals. So here's where if you want to color, you can. You can color this blue, what's blue up here to represent metals. I will have you draw a zigzag line though in just a minute. So metals are going to be shiny, tend to be silvery and solid. They are very soft solids over here, and they become harder solids as you move to the right. They're good conductors of heat and electricity. Malleable means you can hammer them into shape. Ductile means you can draw them into thin wires. And located left of the metalloid. So this is where you really do need to draw a zigzag line. See
Why is there
how
a blank right here?
I may have forgot to put a blank to the left. Oh, I
You
didn't,
answered it.
I answered
That's
it.
cool.
I didn't put the.
Camden is totally paying attention though.
Yes.
That is
All
true.
right, so see this zigzag line right here?
Mhm.
If you start, I usually start underneath boron and aluminum. I go between aluminum and silicon, between silicon and, down here, between arsenic and antimony, between SB and TE, and on top of PO, and down. This is your separation. If an element touches, other than aluminum, aluminum is an exception, if it touches the zigzag line, it's a metalloid. So when they say to the left of the metalloids, that's what they're meaning. So you may want to put that zigzag line on your periodic table. Now you're going to see up here, this particular image, whoever created this image, chose not to include PO and AT. So it depends on the periodic table whether they include that or not. Now just know that that zigzag line goes like this, and if it sits on it, except for aluminum, or touches it, it's a metalloid. So nonmetals are the purple ones. They can be gases. They can be dull, brittle solids. They're, we have one liquid, bromine. They are right of the metalloids, or with the exception of lonely hydrogen. Remember, hydrogen is only over with the metals because of its one valence electrons. Sometimes periodic tables put a little space here and let hydrogen up a little bit higher, just so you know it's not a part of that metal group. It's not. You got progress reports, so. You'll get, help me remember, y'all get progress reports.
Oh,
And I found a mistake in my canvas. I didn't have something set up right, so it's actually lower than what canvas is showing.
no.
Sorry about that. Metalloids, solids,
So is it what canvas is showing or what's on the thing?
they're both correct now, but I didn't have a percentage set up right in Canvas, so Canvas was boosting it, and I was going crazy. I spent all afternoon beating my head up against the wall trying to figure out why they weren't matching.
That's
And it
awful.
was just because I didn't have my percentages set right.
So now,
All right, so solids, they're semiconductors. You'll find a lot of this like silicon, and I forget what the other one is that you'll find a lot in computers. Their physical properties are metals, but they act like nonmetals. So did you get these first before you go checking on the grades?
Yeah.
How did you know what he was fixing to do?
I heard it.
yeah, I got those.
Oh. All right, this last part I will talk about, but we're actually going to practice this tomorrow. So I'll probably go review it. So this is what we call a Bohr model. This helps us to see how atoms can react based on the outer energy level and what's there. So these are named after Niels Bohr, who had the idea that electrons were in fixed orbits, kind of like our solar system and our planets. But remember, these electrons kind of bounce back and forth. So this is kind of where they spend the majority of their time, but they do move around. So a couple things you've got to be able to do to draw these. You have to know the number of protons. We get that from the atomic number. We have to figure out number of neutrons, and we do that by subtracting mass number and atomic number, or number of protons. We put that information in the nucleus with the symbol. They don't have that written there, but it's good to have the symbol there for that element. We use the period number to know how many circles to draw around that nucleus. And then we use the group, then we start distributing the electrons. Remember, we start in the center, 2 goes on the first one, then up to 8, and so forth. And you're going to start always with level 1, work your way out, and then you can check if you did it right by the group number. If in the outermost ring you have the group number, you know you've drawn it correctly. So we're going to deal with that tomorrow. So what we have for the rest of class is you're going to have a review sheet kind of notes from this unit and a little bit more practice on a table. And then you've got 2 videos that talk about the periodic table. So let me get out of this.
What do you
And,
put for number 6?
huh?
Check with them. She's got
It's the same as the.
group number.
Group number. So on here, you've got 2 videos that talk about the periodic table. And then down here is what the sheet I'm giving you. So you may want to do this first, because you can always watch the videos at home and answer those questions.
I'm not.
So this first part up here is, and you may want to use colored pencils if you're doing it on the sheet, or you can different colors on the Cami. That's my mess. I had it shut out and then I had to message somebody and forgot to shut it out. So number 1, follow the directions. This is draw 4 protons in the atom to the right and label them with their charge. So to do that, I would choose a color and draw a circle like that. So it's going to go inside the nucleus. Then I would choose a different color, and it says draw 5 neutrons. So with your other color, draw 5 neutrons. Neutrons do not have a charge, so you're not going to have anything in that circle. Then it says draw 4 electrons in the atom to the right. Place 2 on the first energy level and 2 on the second. Label their charge. So you can do a circle with those with another color. I don't have another color. This, for example, on this ring here, you can draw a circle and put a minus. Draw a circle and put a minus, because it has to hold 2. And then it says minus, minus. So I'm kind of doing the first one with you here. Then it says, what element did you draw? Look at the protons. How many protons do you have? How many pluses did we draw?
4.
So go to periodic table, find number 4,
B.
and write its name out,
How do you say it?
beryllium. And then it says, how do you know? What else do we call that little number up here?
Atomic number.
Atomic number. So pretty much it is following just the directions. So 6, 7, and 8, you're labeling this information. And I had you do it on your periodic table when we went through the notes, but you may have to find your notes to label each piece. And then in the chart, remember in the chart here, like we did yesterday, for atomic number, I put a dot. Mass number, we put P plus N. Number of protons, we put a dot. Number of neutrons, we put mass number minus P. And then number of electrons, we put a dot. The ones with a dot are the same number. And then this tells you how to find this. We use the atomic number and the periodic table to find the element symbol. So I'm going to let you work. If you have questions, you ask. And when you're done with that, you can work on the videos, or if you still had